Very good morning all. I have prepared this circuit trial diagram. I'll delete this and I will show you how to prepare this so that you will understand the working of this electropneumatic systems. So I'll show the circuit diagram for uh, A plus B plus A minus B minus. Because it's very simple. Once you get the idea how to prepare that, you can prepare any one. So here we have to consider the double acting cylinder very first. Then we have to prepare the labels and all. Initial position we need to give as 0, and you have to give label as 1 is 1 and 1 is 2 for these two positions, that is 0 and 100 mm, that is 0.1 meter. So here I am giving the same input for the cylinders. Then we have to take a 5x2 or 4x2 ball. I'll connect this with I'll need maximum space for preparing the electrical circuit diagram, so I will just shift this upward, and then left to left and right to right connections for the cylinders and the final controlling valve, or we can say the directional control valve. I'll need one more cylinder for process B, and one more 5x2 double-sided valve. For this double-sided valve, that will depend on uh, the properties of the 5x2 valve. First I need to give properties for this cylinder. This is 2s1 for 0 and 2s2 for 0.1. Okay, then we do need to check the properties for this. This is electrically operated, that is solenoid coil should be considered here. Same thing is applicable for this second 5x2 ball also. Air supply for these two cylinders at port number 1. Then the properties of this solenoid coils, we need to give label for this coils, that is 1m1. Click on the green signal that you can get when you take the cursor to that position. Properties 2m1. to M2. Then we need to prepare the electrical circuit diagram, and for that you will need this 24 volt line and 0 volt line. Okay, now this is the individual line. That means we need to consider different components required for the electrical circuit diagram. Then this is the first manual switch. I'll call this switch as S1. Okay. Mm, I'll delete this. S1. Then we will need a feedback from the last process, that is A plus B plus A minus B minus B minus is the last process. Means 1s1, 1s2, 2s1, 2s2. This will be the positions. So finally the rod end of cylinder B will come at B minus position, that is 2s1. So we need to take a feedback from that position. So we'll find one switch, electrical switch, which will consider that position. So that is what the make switch we will need. First we'll connect this with the terminals, and we'll give this as 1s1. Here you have to consider the switch with roll. If we give name to this switch as 1s2, then the story will be different. You can see it's open now. Okay. Also it's not 1s2, it's 2s1 or 2s2. You can see 2s2. It's open. Now I will change it as a 2s1. Now you can see it's closed. So that is the story. When you software will consider, or it will understand what is the status or where is the rod end of the cylinders A and B. We will call this as cylinder A. This is as cylinder B. So now currently it's this 2s1 limit switch is initially pressed. Then we will need one solenoid coil. Take cursor with the 2 points and then take it over here. So right now first line for the circuit is over. Now 1M1. Okay, we'll check whether this is correct or not, correct or wrong. Mm, Now this is the manual switch. You can see we are getting extension for this cylinder. Okay, and if you activate this, you can see this line is getting opened. This is just a check. I'm doing this manually by applying pressure, but it's a solenoid coil, so that's why the status will be, or the things or the logic is different. I need to give supply to this coil and need to energize this coil. Okay, so the thing is different, but I'm just trying to check what will happen whenever this is energized. Okay, So this is fine, this is correct, the logic is perfect. Now again I will have to consider uh, one more line in order to complete the circuit for this. Then one more, I think one more is required for this. I cannot take another connection from this line. Now I'll have to take a make switch. Okay, make switch is there. Now I'll have to give label to this switch. This is rollers and this should be 1s2, because after getting extension of this rod end will be at 1s2 position, and from that we must take feedback and we need to implement that to get B plus. Now how we will get B plus? If we apply pressure on this side of the wall, then only we will get the compressor out from this wall and it will enter the cylinder from this side, okay, left side line. And this is the required or desired condition. So in order to get this, I will have to energize the coil which is mounted on the left hand side. So how to energize this coil? By taking feedback from the 1s2 position. Again the system is electropneumatic, so that's why we need to consider the electrical limit switch over here, and it must get closed after when the rod end comes to this 1s2 position, and when it is getting close, that will pass on the supply to this 2m1 coil, so it will energize the 2m1 coil. Okay, now next, if you need, you can consider one more limit switch over here, just to check what is just to check the thing that we have discussed, that is using two limit switches in a single line. Okay, so this is 2s1 and I'll consider this as a switch with roll. Okay, so this is initially pressed, you can see this is also switch with roll, but one rod end is initially at 1s1, it's not at 1s2, so that's why it's open. Then I need one solenoid coil. I need to connect it over here, and then I need one 0 volt main line. Okay, so I'll check whether it's correct or not. Okay, yes, this is the initial condition. I'll press this, and 1s2 is getting pressed, but this is not getting pressed. So there is some problem. Switch with roll. It's correct. I'll see what will happen when we change this things. Stop and we'll check for this again. That is switch with roll. got the error. Mhm. We need to give name to this coil as 2M1. Now it will work. Okay, yes. Yeah, perfect. So you need to check the errors continuously, because you will not get that error prompted here. So you need to find out manually what's the problem. First you have to draw the electrical circuit diagram on paper, and then you will have to prepare the electrical circuit diagram, same electrical circuit diagram here, by using this switches or the tools. Okay, then the next line we'll have to prepare. In this session I will show how to prepare the electrical circuit diagram for this sequence, and I'll show you how to get the delay and all. Uh, but there won't, I will not go in detail. So this is just for giving you the idea how to use this software for preparing the electrical circuit diagram. So next, now we'll consider only one switch over here, and we'll check what will happen by using by using only one switch. Okay, now switch which is required over here, it's a switch with role, and the label is 2s2. Yes, after getting B plus, this is for A plus, this is for B plus, B plus number rod into result 2s2 position. So here you will get this initially open. uh, then we'll need one solenoid valve, and 0 volt line. Okay, so name for this is 1M1. Then next, it's very simple now. Once you get the logic, it's very simple. One make switch is required, then one coil is required. That's it. It's very easy. Anyone can prepare this circuit diagrams. Uh, See now how much time is required to prepare the one line. Okay, hardly 1 or 2 minutes are required to prepare one line. So you can understand. The name of this is 1:2:2, 1:1. Okay, and name of this is last coil means 2, sorry, 2M2. Okay, so name of this is wrong, it's 1M2. uh, so such errors can come. See, 1M1, then 2M1, then 1M2, and then 2M2. Okay, so this is if you want to introduce one more switch over here, you can introduce. Aite konta ye, see, after getting B plus, it will be at 1:2 and 2:2. Rod and of both cylinders will be in the respective manner, that is 1:2 and 2:2. So 2:2 is already there, only 1:2 need to be introduced over here. And after getting A minus, rod end of cylinder A will come at 1:1, and rod end of cylinder B will be at 2:2. So 1:1 is already here mentioned, and only you need to consider 2:2 over here. So that's it. Here 1:2 and here 2:2. So you can introduce if you need, if you want to check Now we'll see the working of this. Yes. We'll check this one by one, stepwise. Yes. Current is there because circuit is closed. Then yes, it can be seen perfectly. Uh, left side left side line will have the flow intake flow for the cylinder, and this will exhaust the air into the atmosphere through port number 3. Okay, next. Yes. Oh, 1s1 is open because rod end of cylinder A left 1s1 position, so 1s1 is open. Now rod end of cylinder A will be in between 1s1 and 1s2. Then next, yes, 1s2 is getting pressed. The logic can be seen perfectly in this electropneumatic system because the things which limit switch is getting closed, how the circuit lines are getting closed, how they are getting open, it can be seen perfectly over here. So 1s2 is getting pressed, so 1s2 will close this line and 2m1 will have the supply. Then you can see what will happen in case of this cylinder and the 5x2 valve of the DCV, directional control valve. So rod, now what will happen, the left side block is in active condition. Now the flow will be according to this. Left will give supply to the cylinder and right will exhaust from the cylinder. Okay, so here 2s1 must get open and 2s2 will get closed after some time. So you can see this 2s1 will get open. Yes, perfectly. So 2s1 2s1 open झाल्या दोन्ही lines, and now 2s2 will get closed. Now this circuit will be closed, and you can see the 1m2 coil will get energized after this step. Yes, perfect. So I think this electropneumatic system will clear your all the concepts than the pneumatic systems. Okay. So what I will prefer, if you are having any kind of doubt regarding the concept how the system is working, also pneumatic system, and if you want to clear doubts regarding pneumatic, electropneumatic and the PLC, and you just prepare the electrical circuit diagram and the solenoid circuit diagram like this, and you just go stepwise. Okay, so you will understand how these are getting closed and open, or we can say the pressed and unpressed. Okay, so you can put the things in the positions by using insert and text over here. You can put the names over here. Okay, so then next 1m2 coil is getting energized. Then see whenever it is reaching at 1s1, now this is getting closed. Then next is 1s1 is getting closed, and you can see how this will come back. So yes, 2 and 2. Yes, some error is there, I think. I'll run this again. We'll check for the last line. Hmm. First close, then A plus, then B plus, then A minus, some problem is there, I think, with this cylinder and this corresponding position 1s1 and What I will do, I will insert one more switch over here. We will check what exactly problem is there between these two in this line, because we are getting output up to this line. uh, the label is switch withdraw test 2. Check again for this, because the logic is perfect. There is no any problem with the logic. A plus, then A minus. Why this is getting, there should be some error. Switch with role. This is 1s1, because whenever the rod end is coming to 1s1 position, this should get pressed. Initially this is pressed, and later on this will get open, and this should get closed again. It's not happening. Uh, Introduce one more next switch. Name for this switch is 1s. Name of this coil is 2n2. Label 2n2. Everything is perfect. Yeah, this is wrong. I need to consider 0 volt. So that's the problem over here. The circuit was not getting closed. Oh, oh, oh. Stop. Play. Okay. Yes. Step wise. Single step. Yes. Press. Then closed circuit. Active. A plus. Now you can see 1s1 will get opened. Yes. Perfect. Then 1s2 here will get closed, and here also. You can see 1s2 closed. 1s1. Okay, wait. What I will do, I will just introduce one more limit switch over here. The name of that switch will should be 1s1. Okay, switch 1s1. So uniformity will be there. 1s1. So can be seen very nicely how the system will work. You can see every switch in this line is open. Only this S1 is not. I have closed this. Now you can see red color. So all these are in closed circuit. Then it will energize this coil and it will activate the left side block. So here you will get this. Now the rod end will now start moving towards 1s2. It will leave 1s1 position here. So you can see 1s1 open wheel आणि 1s2 1s2 क्लोज होतील. So you can see first 1s1 open झाला, इथला पण 1s1 open झाला. So this line is now open. Now you can understand the difference in between the two cases. uh, One case 1s1 is not was not there, and second case is 1s1 is there. So immediately after getting or after starting the first process, this line is getting opened. Okay, and in earlier case, that is when the 1s1 was absent, uh, this line was not getting opened as soon as this first process was starting. So that is the difference. Okay, immediately this line is getting opened. Now next, yes, you can see 1s2 close, 1s2 close, 1s1 is already open. Now what will happen? 1s2 is closed means 2n1 coil will get energized, 2n1 is energized, and effect can be seen as per that energized coil. So now 2s1 will get opened, 2s1 now will get opened, 2s1 now will get opened, and next step 2s2 will get closed. Okay, that is the third output. 2s1 is open, 2s1 is open. Now 2s2 and this 2s2 will get closed. Okay, so this 2s2, this 2s2. Now every time we are getting some errors. I don't know. Stop, run. Okay. Now why this is getting shifted? I will stop here and will remove this switch 1s2. So remove the switch. This one. We'll connect these two and we'll check what is happening. Logic is not wrong, but some error is there. That can be because of the software. Now we'll see stepwise. First is close, A plus, open. Second close, B plus, open. Third close, A minus, open. Last close, and this is perfect. And you can see here, if I'm keeping this in rest condition only, you will get number of cycles like this. Okay, so stopwatch, just open that switch. So you can see this will stop whenever the cycle is complete. Okay, the system will start whenever the cycle is complete. Though we are uh, opening this manual switch at one moment, it will not stop. The system will not stop at that moment only. First, it will complete the cycle and then it will stop. Okay, so that is a thing that we are getting just because of the logic that we have developed over here. Okay, so thank you so much for watching. I'll check what's the time. It's 36 minutes, so we can check for timer also. Now where is the timer switch? I think this is for time. Hmm, yes. Test, it's not coming here. It's in the run mode. uh, Now used, we will use over here. We will delete this one. We'll connect a time relay in between this. We can, here we can set the time. Label, will give this name as T1. I will need one time delay pickup switch. Relay switch of delay. uh, a ladder. We will check. I'm not sure about this, but it looks like that only. Now we'll run this. 2, 4, 5, closed. 4, 5 should get closed. Properties, perfect. Chemistry. 0.1 second is 50. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not working. So either there should be any other different pulse relay, push button. Relay with switch off delay. It is called ladder. Switch on relay for ladder. This is not working. Attentive. This is not working. So we'll check the positions of these two. Okay, we will do one thing for this. Okay, we'll change the time. Time is equal to 50 seconds. Now make this as make this as no, 2 seconds. Seconds run. will go stepwise and we'll check whether this there is a problem. There is a problem. Error will come definitely. Uh, we have introduced two coils over here. That is one time relay and then one into coil. We need to yes, it's T1 cancel, delete, delete. We need to take this coil over here. What is this? Uh, we need to connect this over here. Uh, and we need to remove this line also. This one and this one also. So 1s1 is not made for this particular case. It's made for 1s2. Then this coil should be there. And over here, and then to this, and then separate supply should be there for 24 volt, and then this should come here. We must give supply from here to here, and then uh, 0 volt. 0 volt should be there for this new line from here to here and here to here. Okay. Now we'll check the logic. To here it was correct. Then 2s2. So how you will get delay. Okay. So here T1 will be turned on 2s2. You will get a delay. T1, then 1 and 2 coil will get energized. Then 1s1 will get closed, and 1s2 1s1 will get closed, and then 2 will energize. So yes. Still there is a problem. Uh, Label T1, read contact T1, and this is 1 into 1. So some error is that I'm not getting that. You please check out from your side. Uh, Now it's correct. There may be a problem in case of this T1. That is the switch which we need is a time delay pickup switch. It may be this one ready contact or maybe different one. So there is a problem in this case only. Otherwise the circuit diagram is correct. So if I get any solution over this, I will correct it in the next session. So thank you so much for watching this, and if you need I already discussed about controlling the speed. That means if you want A plus uh, slow approach, B plus, delay A minus B minus, then the circuit diagram will be like this. And you need to consider the unidirectional flow control valve in this left side line. Okay, this is discussed in the last session, because as we have to control speed of this piston, means we have to control this flow of compressed air going inside the cylinder. So that's why we need to focus on the air only. It's not a part of this electrical circuit diagram. So let's understand this. It's about controlling the compressed air, not the actuating signal or actuating medium. Okay, so thank you so much for watching this sessions. If I get any solution over this, I will convey this in the next session.